So let's move on to the unique topic on the impact of digital transformation, a use case focusing on carbon capture and storage. We have two executive gentlemen from Curtis Associates, John Curtis and Bertrand Rioux, out of Canada. Thanks a lot for a long time flight. But again, the Open Group has been very thoughtful, and we gave you a session which is at your morning time zone. So John has been building data acquisition, management, and visualization solutions for decades. The Curtis Associate portfolio, if you don't know them, it includes Petrolink, Unidac, EnergyView, and Net Zero Matrix. The group is now developing the EnergyLink unified data ecosystem. We're going to hear more about it from our panelists today. A digital transformation initiative to resolve the isolated data silos which are impacting the climate. Again, I would like to have, to introduce you to the stage. Please, I'm very much delighted to have you speaking about such an important topic. And I'm not sure if your colleague is ready to join. So please welcome me in warm welcome. Sorry. Welcome, Bertrand, on the stage. And thank you so much.
Thank you very much. Thank you, Grace.
Thank you.
We don't like each other. We're going to stand at opposite edges of the stage, okay? So, Bertrand, can you introduce yourself? I think it didn't make it to the screen.
Yeah, so as mentioned, Bertrand Rioux. I've been working with Curtis & Associates Group and Net Zero Matrix for the past about a year, working on data management solutions in the energy sector. Before returning back to Canada, I was actually based here in Riyadh for more than 10 years with an organization some of you may be familiar with called CAPSARC, the King Abdullah Petroleum Studies and Research Center, which works closely with the Ministry of Energy. And I worked closely on some climate policy, climate strategy work there, and then took some of the progress we made working with CAPSARC into private interests and private sector development, which brought me to my work with John. And we'll talk a little bit about the work we do there and my interest in emission allocation agreements to address climate issues in difficult and hard to abate sectors like the energy industry. Thanks, John.
First of all, I'd like to thank Grace for the introduction. I'd also like to thank the Open Group for inviting me to be the speaker at the last minute. We've managed to put something together we hope will be interesting. A little bit different from the talk about EA. We're an SME. 99% of all companies, certainly in the UK, probably here in Saudi as well, are SMEs. Digital transformation impacts them as well. They're pretty unlikely to bring in full EA solutions. So how are we going to build something that's relevant for small companies so we can all benefit from digital transformation in the future? I'd also like to thank Saudi Aramco for having the vision to establish this Digital Transformation Forum initiative. It's the perfect timing. As a matter of fact, the Open Group, I'm surprised they didn't get up and say they're already into digital transformation, because the OSDU is building a solution which is revolutionizing the way in which energy companies are sharing information. And the Open Footprint Forum is a recent initiative which is designing a data model to enable the capture, storage, and evaluation of information related to carbon emissions, which is going to be important to all of us and impact everybody in society. But first of all, I'd just like to share a little anecdote. In fact, the first time I came to the kingdom was 49 years ago, believe it or not, and I was working as an engineer in Ras Tanura. It's a little bit different here then. But anyway, I ended up getting an Aramco ID. So I had an Aramco ID, and then I left and I went to work with other companies, and I came back to work here in the kingdom about 20 years ago, working with the upstream people in Aramco. And eventually I was issued with an Aramco ID, and I went along to the center to get my Aramco ID pass, and he said to me, "Where's your old ID?" And I said, "Well, this is my first time." And he said, "Oh, no, it isn't." And he brought out the piece of paper with my 5 fingerprints on, right? And he said, "You were issued with an ID, and here's your ink fingerprints. You need to give us the ID back." "Well, I don't have it." "Well, you have to pay us 100 SAR. So digital transformation doesn't work for everybody, obviously. Anyway, we're going to talk a little bit about the importance of carbon capture and storage here. This is going to be very important around the world, and it's going to be a key market here in Saudi Arabia, as we will be showing here shortly. So Bertrand and I, we're going to bounce off each other. I'd like to congratulate the fireside, the previous one. That was really good. I really enjoyed that. And we're going to try and emulate that a little bit here. Everybody's seen this picture before. It's in everybody's presentation, the 4 industrial revolutions. But I'm drawing your attention to the graph at the bottom. Anybody any idea what that might be? The graph at the bottom? Yeah, so this is the growth of greenhouse gas emissions since the beginning of the Industrial Revolution, and it's still going up. And we all know we've got to do something about it, one way or the other. So in order to explain how we are using the OSDU and the Open Footprint Forum and how those are relevant to digital transformation, I just want to go back a little bit to first principles. So you've probably all seen this. Since the start of the Industrial Revolutions, 500 billion tons. So if we were to attempt to reverse that and put it back to where we were in a green and pleasant land, we'd have to get rid of 500 billion tons in the atmosphere. Clearly, that's not possible. This graph shows something that's called gross zero. And there's a lot of misunderstanding about net zero and how it's calculated and how it works. And I just want to explain a little bit, because it is important in context of carbon capture and storage. So there are hard-to-abate industries who will never be able to go to zero. All of us in this room are breathing out carbon dioxide. So as a matter of fact, unless we stop breathing, we're still going to be contributing to the carbon dioxide in the atmosphere. So industries such as steel manufacturing, the energy industry will always have residual emissions. And these might be around 50%. So if we manage to reduce emissions by 50%, say by the year 2050, which is when most countries have gone into the Paris Agreement to agree to try and limit their emissions, to bring down their emissions, so that within a certain range for the increase in temperature, how are we going to get rid of those remaining emissions? Because some industries can't be completely decarbonized. So in fact, since we have those residual emissions, we are going to have offsets. And those offsets can come in many different forms. This is my group contribution to that in Indonesia. So we planted, at the time of the Paris Agreement, we planted a teak forest there, and we calculated 3 years ago we became carbon negative. Anybody can do it. This actually cost about 0.3% of group turnover to date. So it can be done. People can do it. Here in the kingdom, there's a lot of mangrove forest and a lot of different projects going on. We call these nature-based solutions, but they're not enough. We can't decarbonize enough and fast enough by planting trees. As a matter of fact, this is about 40 hectares. It's only actually absorbed about 30,000 tons of carbon dioxide, to give you some idea of the challenge. 500 billion tons, and our little contribution is 30,000. So carbon capture and storage is pretty much recognized as being a big growth industry in the future. And the predictions are that it's going to keep on growing exponentially up until around the year 2050. Most of the information I'm showing here is, I should say all the information I'm showing is actually in the public domain. So this announcement by ExxonMobil at the bottom, you can still find it, still on the internet, and basically they're estimating that some 60% of their turnover is going to come from carbon capture and storage. What does that mean? It means that they're going to capture it to reduce their own emissions, but they're also going to sell it. It's actually a negative product. You know, you think about, okay, you produce oil and gas, you sell it on the open marketplace, people want to buy it because they need those products. But actually, companies are going to start paying to get rid of something they don't want, which is the carbon dioxide. So about 5 years ago, when I started Net Zero Matrix, we started looking at what companies were doing. In fact, the first company we saw taking steps towards reducing their emissions and reporting their emissions was Marks and Spencer's, as a matter of fact, and that was back in 2018. So a few years ago, we started building something we call the Carbon Register, and this is another good example of digital transformation. So back then, I got a load of students in Indonesia together, and I said, I want you to trawl the internet and gather the corporate reports of all of the publicly quoted companies that you can find. And this one here is Chevron. So we started gathering the information. Now that information is available on corporate websites as PDF files typically. That's unstructured information. You can't get that information in any database anywhere. Not all of the information in one place. So we started doing this manually. And it took us about 3 years to gather all the information, to bring it right up to date, and to start looking at, well, what are people doing in a particular industrial sector? Who are the good players? Who are the poor players? Are they buying emissions? Are they not? Et cetera, et cetera. Sorry, emission offsets. And we noticed some interesting trends. So here at the top is the first report from Chevron was in 2016, something up around 70 million tons. And then it's reducing, and the yellow line shows their straight line trajectory to net zero in the year 2050. And you can see they were tracking pretty well until 2018, when they reported it, and they were much higher than the target plan for the reduction. They started buying removals. And you can see the removals at the bottom from 2060 onwards. Those are millions of tons of offsets that this is real money they've spent to buy those offsets. And you can see the impact of the purchase of those offsets. The latest one was about 10 million tons in 2024. A lot of companies are doing this. A lot of companies are abating their emissions by getting involved in renewable energy certificates or carbon capture and storage. Elon Musk himself, has sold on the market certificates because he claims, well, I've made electric cars. Electric cars have a certain carbon footprint to manufacture, but over the lifetime of the car, the emissions are much less, so he claims that's a reduction in the emissions. People agree, and they've sold. So he's actually made billions of dollars by selling these certificates on. And this is a growth market. So Bertrand, maybe tell us a little bit about, the emissions here that we see. This again is the emissions reported on their corporate report on the internet, and their mitigation, the mitigation that they're doing, which is shown in yellow at the bottom. Bertrand?
Yeah, so this actually sets a good context for CCS. I mean, we talk about emission reductions from the operation organization. They call it Scope 1 emissions, the direct emissions. Here we're actually looking at the Scope 3 emissions. These are actually something specific called the Category 11. Get around the jargon, the categories. This is basically all of the emissions in the product that an energy company sells. These are the hard-to-abate emissions that industry needs to remove from the atmosphere. And one way to do that is through carbon capture. Now, this organization, this is Chevron, correct?
Yes.
Yeah, this organization is purchasing a mix or using a mix of credit programs or credit mechanisms to offset its emissions. We believe we have 2 million tons coming from carbon capture, which is either purchasing through other parties or investing in it itself, but also in RECs, renewable energy credits, and offsets. So this chart really shows the complex interplay between an organization's reported emissions, whether it's their direct or their Scope 3, and how they can mitigate that. Now this Scope 3, right, obviously they're just addressing their own emissions here. One of the objectives and why this digital transformation solution is so important is we need to scale this up to start capturing a big chunk of these emissions, right? In this case, just for one company. But if Chevron wants to sell CCUS as a service, they have to consider this big number here, right? So this is a problem that needs to scale and scale fast.
Thank you, Bertrand. So just a very brief overview. What is carbon capture and storage? It's actually a complete reverse of what happens in production. So in production, you do seismic, you identify potential plays, start drilling exploration wells, make a discovery, drill development wells, delineate the field, put in facilities, production facilities, gathering facilities, refineries, gathering all of that, create the product, and ship it to the customer. Carbon capture and storage is exactly the opposite. You have a negative product you want to get rid of. So around refineries, around production facilities, around cement plants, etc. The objective is to capture the emissions at source. This is already happening here in the kingdom, in the Upmania field, I believe, in Aramco. Capture the emissions at source, compress it, liquefy it, transport it by some means or the other to a suitable reservoir, subsurface reservoir, where it will be permanently stored. There's already a lot of activity here, but it's just the very beginning, isn't it, Bertrand, of that,
yes.
of those operations? So Bertrand, a little bit about the OSDU. I mentioned the OSDU a bit earlier on. It's very important. It is another open group initiative. We've been members of the open group for most of the time it's been in operation. What does it do? The objective of the open group is to enable companies to share information, not internally, but between themselves. So we've heard a bit this morning about EA, and most of those, that's internal to a company organization to improve the efficiency of the company in order to provide solutions to customers. But within the energy sector, there is a lot of partnering. There are a lot of co-venture partners who work together, and they have to share a lot of information. This has been a bottleneck for a very, very long time. In fact, that was the genesis of the business I started 30 years ago, because people needed to share that information. And the OSDU has built a microservices-based mechanism to enable the sharing of this information. The sharing of the information has become more complicated between companies because of security implications. It's very hard for them to share the information. So that's the OSDU, and the OFP, Bertrand, you've been involved in the open footprint longer than me. Perhaps tell the audience a little bit about that.
Yeah, before I dive into the next technology base, I just want to set the stage. So we're showing 3 different technologies that can be used in an enterprise architecture transformation, right? But going back to what Dr. Darren was talking about earlier today, there's the technology, there's also the people, the principles, processes, and the policies, right? Who are the people using the OS2 technology? Well, this is everyone involved in the technical implementation of these projects, from the subsurface engineers, the geotechnical engineers, to the above surface engineers that are managing this captured flow of CO2, right? What are the policies? Well, these are multiple, right? You have government policies that are coming into place that are restricting the emissions coming out of organizations, so they need to introduce these systems. There's the internal policies that the organization creates to reflect these, external forces, regulatory forces, right? There are also policies related to how do we commercialize these services? How do we make money off of them? Now, in this group here, so this is a forum, right? But it represents a technology that has emerged, a standardized way to represent emissions data, whether that's the sources of emissions or the sinks, as we're talking about in the case of CCS, or the credits derived from those. The purpose of this technology, right? It's not a sustainability data management software in itself, but to how do we integrate, right, all the data from all these carbon accounting systems to enable these use cases? Because you have flow of information between multiple stakeholders, right? The information about emissions stored underground, understanding what's the capacity for CO2 emissions underground, to the actual accounting for the capture and then injection of this into the subsurface, which involves multiple industries, different operators, also those that operate the transportation infrastructure, or the pipelines or ships, right? That get the emissions there. So there's a lot of complex accounting that has to be done. The Open Footprint Forum and the data model standard that this group has created, provides a mechanism to facilitate that flow of information. Then the last piece of technology we have here is, well, we call it the PACT specifications. It comes from a group that also developed the standards around emissions accounting used by corporations that focuses on the emissions embedded in products, what we talked about earlier, scope 3, but how do you then standardize the transfer of this information between parties? And this becomes very interesting in the case of carbon capture. And actually, PACT has recently introduced entire attributes within its specification standard for documenting CCS operations. Now, it doesn't specify how this information is collected, how is it stored, but only how it's communicated. So we need to integrate this system with other systems that deal with that technical underpin. And we're looking at here, right, using PACT to build this product PCF, product carbon footprint network, right, that are either derived from, right, or use CCUS. When I mean derived from, CCS, which we talked about, carbon capture and storage, is just one piece. There's also U, which is utilization, where you may take that captured carbon and put it into some product, right, which can then be represented as a low carbon product or an emission reduction effort, which you can then commercialize, right? But you need that commodity differentiation, those mechanisms to capture that information and package that with your product. Like when you go to the store, right, and it has some sort of environmental label, how many calories are in this? Well, in this case, right, what's the impact on the climate?
Thank you, Bertrand.
Yeah.
So a little bit about, maybe we talk a little bit about the digital transformation, and so we have a lot of systems in the field that are capturing information. So typically any industry, take an aeroplane, it's got tens of thousands of sensors, it all comes together and it's analyzed and it produces the instruments that the pilot used. It's the same in the energy industry that we've been involved with the Petrolink side, where we have a lot of data, a lot of raw data, uncalibrated data that comes in from sensors that needs to be processed, and then that needs to be made available to people. So typically, the system of engagement might be connected directly to the system of record. System of record, Oracle perhaps, or some other back-end database where all the information has gone in, and then people have applications that run on top of that. So we see the OSDU as being a system of record in its own right, but also being a middleware solution. The middleware solution, the way in which information can be exchanged with third parties. Actually, even within an organization, it has a role to play, because even within one organization, there are quite often limitations for the exchange of the information, which is the internal data silo problem. Bertrand, you comment any further on that?
Yeah, so John, when we talk about system of engagements here, we're really talking, again, going back to the people that are using these systems. How are they engaging and accessing it? In a way that there's some commonality, right, in the source data, right? Obviously, they may derive different outputs from that, but there's some commonality. Now, this also gets down to the level of, we talked about agentic AI and AI systems. You know, how can you use the system of record and secure middleware to give AI access to the appropriate data? Now, there are many areas in CCS where this can be useful. One of the big challenges in CCS projects is permitting. So getting permits for these underground reservoirs where you store CO2. All right, so one of the, a presentation John and I attended several months ago was looking at the use of AI to facilitate the permitting process, right? But you need that AI to have access to great data, and standardized data and data of high quality. And that's where we believe these types of systems can help those people interact with that data in a better way, in a more efficient way.
Yes, so it might be trying to access data which is not owned by the company that's running the agent, and therefore there needs to be a process in place. Rather than having instances of the data in every location, you have the data in a single location, perhaps cloud-based, in a single location, but other agents or other people need to access that information, so you need access control systems, and you need a separate place where that process can take place, thereby protecting the security of the individual companies and their systems of record.
Exactly, and that's where OSDU as a middleware has a lot of potential. We won't go into the details of the technology, but as John mentioned, legal entitlements and legal policies, access control list, it's a very mature system as far as modern microservice architectures go. Yeah.
So moving on, a little bit about the data model itself, because I know there's quite a lot of interest in that. And the data model was developed by you would call them domain specialists?
Yeah, from a range of sectors, primarily actually on the gas industry, but also other IT and IT services, as well as one of the other platinum members, Fujitsu, has contributed to its development. Now, the idea here is to have some consensus around, right, how different people view and capture emissions data. So it's what we call an emission activity-centric model, right, which we can capture data from different systems, right? I talked about earlier creating an integrated system for existing carbon accounting solutions, right? How can you bring that data together in a consolidated way? You can have data from ERP systems, right? Traditionally, a lot of companies, including the big international oil companies, and are using Excel and PDF and reports. So how do you bring that into a structured system, right? To represent your operated assets, your non-operated assets, your joint ventures, but also your financial implication or financial accounting and production, right? So the view here is how can you then bring that data into a standardized data model. This is the open FERPA data model, and building the communication layers, the APIs to achieve that. So then that information can be fed right to your partners, the customers, regulatory reporting frameworks, right, regulators and so on.
So I think I'm right in saying that in common with a lot of open group initiatives, the idea is subject matter experts come together from many different fields, for example, in the field of security, to have the legal entitlements to build all of the security part of it. They come together and work as teams, and this is what we're hoping to do. I think Engineer Rashid, tomorrow we're hoping to define what those work work teams would do within the digital transformation network. But within the Open Footprint Forum, there was a team building the model, another team defining how it was going to be released. So at the moment, this data model is available to members, but the objective is it's open source and it will be provided to the general public, and people can do it. Now, I mentioned SMEs later on who may not have the capability, the facilities to design all this themselves. So reference implementations are important. Open source reference implementations that can be downloaded, released. This was the success of the Energistics group, which is now part of the OSDU, which looked at real-time data streaming for oil and gas data, is to provide reference implementations and, very importantly, APIs. How do you connect onto this? How do people share that information using various APIs? And so one of the objectives of the Open Footprint Forum, which we believe is very valuable in the definition of a carbon capture and storage model, is the fact that this is all open source and that companies can take it, they can implement it internally, even small companies with limited resources, and they can build something which will bring value and enable them to report. Where do these reports go, Bertrand? I think at the bottom we've got some ideas of some of the people who want to have this information, this carbon information.
Exactly. Yeah, so there are many partners here, right? So the idea is having a microservice architecture one of the motivations for this is to connect it with lots of people. They may just have a part of the solution or need to use a part of the platform, but it's making sure that that's accessible to everyone within the network. Perhaps we can move on to the next slide, John. Yeah, so in our case, we're looking specifically at this implementation, right? Standards for the CCS supply chain. So we're looking at three general areas which I've spoken about already, right? The geotechnical data, right? OSDU provides a very robust platform to capture this information. It's cloud native, and as we discuss later, has some AI capabilities, right? Within OSDU, there are existing standards, John mentioned Energistics, that assist us in how we define the exchange of that data between parties. So this may be operational data coming in from the capture or the injection of that information underground. All of this information needs to flow between stakeholders. We're currently looking at integrating what's called the production data management system, ProdML standard based on the ProdML standard from Energistics to manage, right, this data, provide this high performance system. And then the last piece, obviously, is the carbon accounting. Taking this data, mapping and transforming it, right, to represent the underlying emission activities, which are used, right, then to derive the product carbon footprint statements we discussed about, the carbon credits, these sort of paths to monetization, which John and I will talk about, right, at the close of this presentation as we approach quickly. Yeah. But I don't think we need to go into too much detail here since we are short on time, and I think this is an area where we can dive into more detail if there's time, during the member session over the next day, looking at the structure of the data model, and then how do we integrate that, right, with the OSDU data platform, connecting the representation of emission activities, right, with these specific data domains that are expressed in the OSDU. So we have subsurface data, reservoir data, right, where the CO2 is being stored, and then this production DDMS. How do we then integrate these two systems? So John mentioned creating reference implementations. This has been a big effort of our company currently, is then developing these connections between them. So we have this consolidated reference architecture.
More on that later, perhaps tomorrow, Bertrand.
Yeah, so John, we had mentioned the role of product carbon footprint, and obviously, what are the drivers, what are the policies behind, right, doing carbon capture? Regulation is a big one, but monetizing those, selling these services is very important. So perhaps, John, you could walk us through.
If people are going to do it, they've got to make money.
Yeah, you can walk us through.
As usual, business is the driver here, and currently carbon capture and storage is quite expensive. The price needs to come down, needs to be driven down. That might be driven down by government regulation. It might be because of cap and trade schemes. The cap and trade scheme in Europe enforces the fact that companies must decrease their emissions, they must abate their emissions. If they don't do so, they have to buy the offsets on the open market. That's typically trading at 80 euros a ton at the moment. That's only in Europe at the moment, but who knows? A carbon price may eventually come in depending on pressure from governments, etc. But the end-to-end, the digital transformation of this whole process, all the way from a sensor to capture the information, the validation, the verification, somebody needs to go in and verify that information, and then monetizing it will almost certainly involve something that's transnational. and the transnational technology that we have that will move seamlessly between different countries around the world is the blockchain. And so we built a blockchain, a parity substrate blockchain around that so that we could take the information that was captured, validate the information or make the information available to a third party to validate it and then transfer that onto a blockchain where it could be monetized. Bertrand, want to pick up on that?
Yeah, so there are a lot of technical components that go into, this digital transformation strategy, monetizing, right? From having a register of the emissions data, John mentioned this sort of idea of blockchain and contracts, to then take that information as an input to some sort of instrument, right, that you use to monetize or exchange, right, these services, right? Feeding that into regulatory reporting mechanisms, so this is an important, people, right, in our enterprise architecture. And then obviously the other third-party applications that build on top of that, whether it's client-facing, customer-facing applications that can pull from this data so you can expand beyond, right, to new use cases. In our case, scaling carbon capture and storage.
And there are a lot of people interested in that information. Yeah. Government regulators are interested in that information. The carbon auditors need to have access to it to provide that verification. Data assurance, the technical data insurance market, the stakeholders, the shareholders in any one particular project. So for example, we've been looking at a project in offshore Holland, Portos project, I think it's called, Bertrand, and that project has got multiple people feeding in carbon dioxide into the pipeline stream. It's already active. They have to look for impurities. People have to satisfy certain requirements. They have to prove how much they're putting into the pipeline stream, etc. So I think we've got 31 seconds left, Bertrand. So just to finalize, I'd like to personally thank the Open Group for my membership. We're members of the OSDU, we're members of the Open Footprint, and now we're members of the Digital Transformation. We have derived huge benefit from the work that's been done by the other members of the Open Group, and I'm sure, Engineer Rashid, that's going to carry on with digital transformation. Thank you very much, everybody, for listening to us today.
Thank you, John.